All right, in today's lesson here, we're going to take a look at solving for formulas here. So we're going to get various formulas. Some you know and seen before, some you haven't, or some are just arbitrary relationships between several variables. And we want to look at isolating for that individual variable given. So let's take a look at our first example here. This is a common one that you've probably seen before. This is the perimeter for the perimeter of a rectangle. So let's say this is my length, these are my width. You can quickly see the perimeter of the rectangle. In this case, the perimeter of the rectangle is the distance around the object. That can be expressed as 2L plus 2W. So let's take a look at this problem, and let's suppose that they say in this question, I'd like you to isolate for, let's say the question is requesting to isolate for the variable W. If the question is looking to isolate for the variable W with this problem here, I have to get rid of the 2L. I have to get rid of the 2, and I want to isolate for the variable W. So in this case here, I'm going to have to subtract 2L on both sides. So P minus 2L is going to be 2W. And again, I want to get W by itself. The 2 is in the way. The operation between the 2 and the W is multiplication. So I divide across by 2, and we get W is P minus 2L over 2. And therefore, I've now isolated for my variable W and express W as P minus 2L divided by 2. All right, let's take a look at another problem. So for the next problem here, this is a common one. Obviously use this as the area of a rectangle. Area is length times width. And let's assume in this question, they're asking you to isolate for the variable L. So in this case here, I want to get L by itself. The W is in the way this time. And the operation between the L and the W is multiplication. To unravel that, you have to divide across by W, in which case here I get A over W equals L, as W divided by W is 1. And again, if the left-hand side of the equation equals the right, you can rewrite this as the right-hand side of the equation equals the left. And therefore, I've isolated for W, and L equals A over W. Let's try another. So for this problem here, again, now we want to isolate for X. The issue with this question, you'll see, is that the X variable is on both sides of the equation. So I have to bring these on the same side of the equation. Before I do that, I'm going to have to distribute this 2 into this binomial. So I'm going to get X equals 2 minus 2X plus Y. So now again, I want to go ahead and collect like terms and solve for X. So I'm going to bring the X's to one side, in which case I get X plus 2X equals 2 plus Y. And if someone asks you what is X plus 2X, X plus 2X is 3X, and that equals 2 plus Y. Now you want to go ahead and solve for X. So you're going to divide by 3 on both sides of the equation. 3 divided by 3 is 1, in which case here I get X equals 2 plus Y over 3. And now I've isolated for the variable X in this equation. Let's try another. So for the next problem here, we have our A equals RS over T. And I'm being asked in this part of the question, can we isolate for the variable R? So I want to get R by itself. So for me to get R by itself, the S and the T are in the way. You'll notice here one technique you always want to use is when you are dealing with fractions, you want to get rid of them. So in this case, you're going to multiply across by T. So multiplying the across on the left-hand side by T. T divided by T is 1, they cancel. I end up getting T times A is R times S. And then I want to solve for R, so the S is in the way. So I'm going to go ahead and divide across by S on both sides of the equation. These cancel, and end up getting here that T times A over S equals R. And again, you can rewrite that with the R on the left-hand side, just kind of rearranging this. And now I have my variable R isolated. Let's take a look at another. So let's take a look at the exact same question. This time what they ask you to do is isolate for T. Same strategy, and nothing will change. You still want to get rid of the fractions and push those fractions to the numerator. So again, I'm going to multiply across by T here. Just like before, and again, the T's will cancel. And again, I'm left with T times A is R times S. Now you notice here I want to solve for T. So now the A is in the way of me solving for T. The operation between the T and the A is multiplication. I'm going to have to go ahead and divide both sides by a. Doing so, a divided by a is 1. I get t is rs over a. And now I've isolated for the variable t. Let's take a look at another. So for the next question here, I've got x on both sides of the equation. They want me to isolate for x again and get x by itself here. So again, before I do this though, we're going to want to go ahead and multiply across by 2. You're going to want to get rid of those fractions first. You don't want to distribute the half into this binomial and have to deal with even more fractions, as it'll generate 2. So go ahead and multiply across by 2. So I get 2 times x is 2 times a half times 1 minus x plus 2 times 3y, in which case here we get 2x. And 2 times a half is just 1, so that cancels itself out. I just end up with 1 minus x, and that becomes plus 6y. Again, I'm looking to solve for x. I have to bring x's to one side. So I'm going to add x to both sides. I get 1 plus 2x plus x equals 1 plus 6y. 2x plus x is 3x, is 1 plus 6y. Divide across by 3. Boom, boom. And we get deletion there on the left-hand side. 3 over 3 is 1. You just get x by itself, and I get x is equal to 1 plus 6y over 3. All right, let's take a look at another problem. So for the next question here, I've got 10 times a plus x equals 8 times a minus x. Again, I'm looking to isolate for x. Once again, we have to distribute this binomial so we can break this apart, in which case I get 10a plus 10x is 8a minus 8x. I'm looking to get the x's to one side, so I'm going to go ahead and add 8x to both sides, and likewise I'm going to subtract 10a on both sides, just rearranging this. When I collect like terms on the left, I'm going to get 18x, and on the left-hand side, minus 2a. X is minus 2a over 18, which is negative a over 9. So in this case here, my value of x is going to be x is equal to negative a over 9. Let's take a look at our final problem here. So for this one, same idea. We want to get these x values, and I want to go ahead and solve for x. So I'm going to distribute the 4 into this here. It's going to give us 4a plus 4b plus 4x plus 3a plus 3b minus 3x is 8a. I want to go ahead and collect like terms here. So I can collect up the a's, I can collect up the b's, I can collect up the x's, in which case this gives me 7a plus 7b plus x this time equals 8a. And isolating for x here, we're going to have our 8a, subtract 7a on both sides, subtract 7b on both sides. End up getting here x equals a minus 7b. And now I've isolated for a. Let's just take a look at one more problem here regarding this. Suppose I gave you x, or y I should say, equals a, b, c times d, and I asked you to isolate for, let's say, the variable c. If you did get something like this and you were asked to isolate for the variable c, a common mistake that students sometimes make is they say, okay, well, I'm going to first, I got to get rid of the a, so I'm going to divide by a. Then they say I'm going to get rid of the b, right? So then they write this down. I should have put an a there, I should say. Divide by a, right? And these cancel, so I get y over a equals b, c, d. And then they say, okay, I'm going to get rid of the b, so I'm going to divide by b. But then you end up having to divide this by b. And obviously then when you divide the d again, it gets messier, messier, messier. So in the event that you're looking to get rid of multiple variables and they're all through multiplication, you can make the observation that if I'm looking to isolate for c here, the a, b, and d, because multiplication is commutative, I can put these together and write this as a, b, d times c. So if I want to isolate for c in this case, I can divide across by a, b, d on both sides of the equation. And if I do that, that becomes 1. You get y over a, b, d equals my variable here, c. All right, that concludes today's lesson on solving equations with working with formulas here. Thank you.